Alright, so a little kinematics tutorial for you. I'm going to go over some questions. In this question, an Indy's car's velocity increases from 6 to positive 38. So that leads me to say that the VI is 6 meters per second. The VF is 38 meters per second. And it does that in a time of 4 seconds. Question then asks, what's the acceleration? These are all vectors, of course. The acceleration is VF minus VI over t. So my acceleration is going to be 38 minus 6 over 4, which gives 32 over 4, which gives you 8 meters per second squared. And that's a positive 8 meters per second squared. That's the average acceleration. So it's speeding up by 8 meters per second every second. Okay, so question 2. A stalled car starts to roll backwards down a hill. At the instant that it has a velocity of 4 meters per second down the hill, the driver is able to start the car and start accelerating back up. After accelerating for 3 seconds, the car is traveling uphill at 3.5 meters per second. Determine the car's acceleration. Alright, so you got a car, or a hill, with a car on it. Give it some wheels. Alright, so it is going down the hill 4 meters per second. That's the initial speed. I'm going to choose down the hill as being the negative direction and up the hill being positive. I can choose whatever I like, so that's what we're going to choose. So VI is negative 4 meters per second. Then they're going to accelerate. Once they get to a certain point, they accelerate up the hill. So the acceleration is going to be positive. We don't know, though. We're trying to figure that out. But we know it's going to be positive because it's up the hill. They accelerate for a time of 3 seconds. And eventually they end up going a speed up the hill, VF, of 3.5. So my VF is going to be a positive 3.5 meters per second because that is up the hill. Alrighty, so we need to calculate the acceleration. Acceleration VF minus VI over t. So you take your final speed, 3.5 meters per second, subtract a negative 4 meters per second, divide that by 3 seconds. Okay, so that gives you 7.5 meters per second up top. Excuse me, divide by 3 seconds. Okay. If you don't feel like mental math this morning, we'll bring up the calculator. 7.5 divide by 3 gives us 2.5. It seems like it should have been a mental math question, doesn't it? So 2.5 meters per second squared. That's our acceleration. And it was indeed positive, as we predicted it would be. Alright, question 3. A bus is traveling along a street at a constant velocity when the driver steps on the brakes and brings it to a stop. VF equals 0. In 3 seconds. Time 3 seconds. So if it comes to a stop, VF is 0. And it does it in 3 seconds. If the brakes cause the bus to accelerate at negative 8.0 meters per second squared, and I think it has more to do with the tires in the road than it does with the brakes do, I guess, sure. At what velocity was the bus traveling when they slammed on the binders? Alright, so we know our formula is VF minus VI over t. If that's rearranged, you get the formula. Well, we take AT up here because the t comes up and it's VF minus VI. Then you want VI, so I'll take VI to this side, make it positive, take the AT to that side, make it negative. So I would have that VI is VF subtract AT, which is of course the formula on the wall when you turn your head. Alrighty, so VI, we don't know. VF is 0 meters per second minus your acceleration of -8 meters per second squared for a time of 3 seconds. 8 threes is 24 meters per second is your speed that they were going at the beginning. A positive 24 meters per second. Alright, so I don't think those are too bad, and we're ready to start some new stuff later.